All right, guys, we are back for our last video for Unit 8. We're on Unit 8, Note 6. Unit 8, Note 6 is on the distance formula. Today our lesson objectives are simplifying radical expressions, which again we've been doing all throughout Unit 8, and also can we apply the distance formula. So let's look at our first example. It looks at a helicopter that can fly 450 miles before it needs to refuel. Suppose that a person needs to be flown from a hospital in Minneapolis to one in Chicago. Chicago is 225 miles east and 175 miles south of Minneapolis. Can the helicopter make the trip in one way without refueling? So we have a little picture up here, and you might want to go ahead and at least draw yourself this triangle. We can see that um, here's Minneapolis, and we're going down south 175 miles, and we're going to the east about 225 miles, and there's Chicago. So we went from Minneapolis to Chicago. But now when you're up in the air, flying in a helicopter, you're not going to fly in straight lines like that. You're going to go the shortest distance possible. So the shortest distance is this one here. But the question is, how long is that distance, and can the plane or can the helicopter make it? We can use the Pythagorean theorem here to see what that distance is. To use the Pythagorean theorem, we know that we need a squared plus b squared equals c squared. And we can use our two leg lengths, which are 175 and 225 for A and B. And we're trying to find that hypotenuse, which is C. So if I plug those in, 175 squared plus 225 squared, if I plug those two values in, I end up with 30,625 here and plus 50,625 there. And then adding those together, I get 81,250. And then we know we have to take the square root, and the square root of that is about 285. So this distance here is about 285 miles, approximately, which means my helicopter that can go 450 miles can certainly go 285. So then the answer is yes, it will be able to. Okay, so using the Pythagorean theorem. Now, the Pythagorean theorem gives us the distance formula, and we're going to look at how that works out. But let's just look at what the distance formula is. The distance formula is what we can use to calculate the distance between 2 points on a coordinate plane. So it's the formula that we have used to calculate the distance between 2 points on a coordinate plane. So you're going to be given two coordinates, x1, y1, and x2, y2, and we're going to plug them into the distance formula, which looks like this. We take the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, let's just take a look at practicing some of those questions. In number 1, I have the 2 points 5, -1, and 11, 7. So I'm going to plug those into the distance formula. When I do that, it looks like this. I have the square root. My distance is going to equal the square root of the difference in the x's. So 11 minus 5 squared, and then the difference in the y's, so 7 minus -1 squared. And then I just keep solving that. 11 minus 5 is 6. 7 minus -1 is 8. That's the same thing as 36 plus 64, which is the same thing as 100. So my distance is equal to 10. So after I plug them in, the calculation part of it is pretty simple. It's pretty quick. It goes fast. Notice that in the directions it says, if necessary, write your answers as simplified radicals. Here we didn't have to because we ended up with a perfect square. But if you get down to something that's not a perfect square, make sure you go ahead and simplify that radical. Let's go ahead and look at number 2. In number 2, I have the 2 points -4, 2 and 4, 17. So again, I'm going to put those into the distance formula. My x coordinates are 4 and -4, so 4 minus -4 squared. And my y coordinates are 17 and 2, so 17 minus 2 squared. Now this is a good time to point out the fact of, if I were to change the order, if I would have gone -4 minus 4, I would have ended up with negative 8, which then squared is still 64. Here, I'm going to end up with positive 8, which again squared is still 64. So if I change the order of these and go in a different direction, I'm still going to end up with the same answer. Same thing with the 17 and 2. 17 minus 2 is 15, so I end up with 15 squared. If I would have gone 2 minus 17, I end up with negative 15, which negative 15 squared is still positive 225. So it's okay if you go in the other order. Then I'm going to keep simplifying here. I know that 8 squared is 64. I know that 15 squared is 225. And when I add those together, I get 289. So my distance is the square root of 289, which in this case is 17. Okay. Let's try number 3 together. Remember, you can always pause and rewind and back up in these videos if you missed something or need to see something again. Can always do that. In number 3, we're looking at the 2 points 2, 3 and negative 4, 6. So let's start by plugging it into the formula. So I have distance equals the square root of my difference in x's. That's negative 4 minus 2. And the difference in y's, 6 minus 3. I can keep solving that. Negative 4 minus 2 is negative 6. Be careful if you're going to plug that into your calculator. Whenever there's a negative there, you need to go ahead and put that in parentheses. And I just tend to make it a good habit to put everything in parentheses when I'm squaring it or taking it to a power, because then I don't have to think about it. The calculator does the thinking for me. So here I have 3 squared. And negative 6 squared happens to be positive 36. 3 squared happens to be 9. If I put those together, I get the square root of 45. Now, 45 is not a perfect square. So this is where we have to go back to simplifying radicals, which we've been doing all unit long. I'm going to take the 45 and break it down as much as I can. That would be 9 and 5. That's 3 and 3, which is this 5 just comes down. So this is the same thing as the square root of 3 times 3 times 5. And we all know that we can take this pair of 3's out front. I get distance equals 3 square root 5. Okay. I want you to go ahead and pause the video right now and look at number 4. See if you can calculate number 4 on your own. In number 4, you're looking at the 2 points 4, negative 1, and negative 2, negative 5. Let's take a look at the last question on this front page. It says Tracy's golf ball is 20 feet short and 8 feet to the right of the cup. On her first putt, the ball lands 2 feet to the left and 3 feet beyond the cup. If the ball went in a straight line, how far did the ball go? So I'm going to start off by drawing a picture because I think it'll help us to see what's happening here. So here's the cup that she's trying to get the ball in. Now at the beginning, her ball is 20 feet short, so she's 20 feet in front of the cup, and 8 feet to the right. So if she's standing looking at that cup, then she's 8 feet down here. Okay, so now the question is, there's her ball right now. What is that point? If I consider this my origin of my graph, if this were a coordinate plane, then this point would be 20 feet to the left, or negative 20, and 8 feet down, or negative 8. So negative 20, negative 8 is that point there. Now, after she hits it, after she putts the ball, now she is 2 feet to the left and 3 feet beyond. So 2 feet to the left would be up here, 3 feet beyond would be over there. There's where her ball is now. And that point would be over to the right 3 and up 2, so I'm going to call that 3, 2. And the question is, if her ball went in a straight line here, where is it? Okay, it didn't go into the cup, obviously, because it's not there yet. But if it went in a straight line, where is it now? What is that distance? How far did it go? So now I'm going to take the distance formula and I'm going to plug those 2 points in. Okay, my difference in x's is 3 minus negative 20. And my difference, oh, don't forget to square that. And my difference in y's is 2 minus negative 8. All right, I got you started on the setup of this question. I want you to go ahead and pause the video at this point to finish it off and see how far Tracy's golf ball went. And then when you're finished with that, that's the end of our video. So don't forget to go back to Schoology and take your quiz. Thanks for watching and have a great night.